Hello students, this is Swapna, Mathematics faculty from EDUHUNT, IIT and NEET Academy. So, do you remember what we have discussed in the last session? Yes, we have discussed about the concept of set theory regarding its definition, examples, notations and types of sets. Correct. So, in the today's session, we are going to learn some more topics related to set theory. So, here comes the first topic what we are going to learn today is, it's like cardinal number of a set. Cardinality. What do you mean by cardinality? Cardinality is nothing but you will express elements of a set, correct? So, cardinality is nothing but you will count the number of elements in the set. How many number of elements in the set exist? That is defined as cardinality. Am I clear? So, I'll define the cardinality of set. What I have told? Number of elements expressed in the set are called cardinality, correct? So, the number of distinct elements contained in a finite set, correct? So, this is nothing but cardinality, correct? Yes. There is add-on point to the cardinality point. So, what is other point of cardinality? For example, if you are writing a word, example like BATA, Bata, okay, BATA, Bata. So, these are the elements of some word Bata, okay. How many number of elements are there? Actually 4, correct. But when you are expressing cardinality, repetition is not allowed of any element. Repetition of element is not allowed. So, actually you have to say like it is 4 elements, 1, 2, 3, 4. But it should be distinct. Distinct elements should exist when you are counting the cardinality of a set. Did you understood the second point of cardinality? So, first is like expressing the number of elements, counting the number of elements of a set is cardinality. Well, good. And whenever you are counting, whenever you are expressing, it should be a distinct or different letters but not the same object. Okay, so in that case you have B is fine, 1, A is fine, 2, T is fine, but again A you should not be included over here. So, number of N of C, N means number of elements of cardinality is how much here? 3, it's not 4. So, that is what I am telling you over here. So, example, let me consider another example, 1, 3, 5, 7, 9. How many number of elements are there over here? 5, correct? You have 5 elements. So, cardinality of A set, how you will represent? N of A means what is this defines? Number of elements existing in A set, which is equals to 5. Clear? Okay. Next, set B. Here I am taking a set of vowels. I have taken only 4 vowels, A, E, I, O. So, how many number of elements are there? B. So, N of B is equal to how much here? 4 vowels. Okay. So, this is nothing but cardinality of a set. So, we will get back to next one. While writing a cardinality, you have to keep this in a point in a brain. Repetition is not allowed. So, that is the next important point. Next topic, we are also going to learn about equivalent sets. You have learned about equal sets. This is equivalent set. Equal sets and equivalent sets are different. Okay. So, what are equivalent sets? Consider any 2 sets. Consider any 2 sets. And if their cardinalities are being equal, if their cardinalities are being equal, then you can say like those both are equivalent sets. Just I want to differentiate between equal sets and equivalent sets are not equal. Please keep this in your brain. Okay. In equal sets, the elements are same. Elements of sets are same. Correct. Whereas in equivalent sets, cardinality of sets are same. Cardinality of sets are same. For example, in equal sets you should have, like, let me take 1 comma 2 comma 3 and b is equal to 3 comma 2 comma 1. In both cases, what are elements are existing over here? 1, 2, 3 only, correct? So in both cases you have same elements. In both sets you have same elements. So these both are equal sets. Whereas in equivalent sets, how can you say an equivalent sets? Let me take A is equal to 1 comma 2 comma 3 and B is equal to 3 comma 4 comma 5. These are not equal sets because you do have different elements in sets A and B. But the number of elements, how many number of elements were there over here? 3. So n of A is equal to n of B is equal to 3. Their cardinalities are being same but elements are not same, right? So in that case, equivalent sets are said to be if their cardinalities are equal. Then you can say like equivalent sets. Just have a glance of the slide, children. Okay, the finite sets, of course, whenever you are counting, whereas in equal and equivalent sets, in both the cases you should consider finite sets. If it is an infinite sets, you will not have to pick up a last element, so that you cannot able to find out whether it is countable or uncountable. So you have to consider finite sets for equal and equivalent, right? Are equivalent where which have the same number of elements. This is an add-on point to the given case. Same number of elements, whereas in equal sets you have same elements. That is a difference between equal and equivalent sets. I hope I am clear with this. Okay, chalo. If the sets A and B are equivalent sets, then n of A is equal to n of B, where A and B are equivalent. Clear? Okay. So let me consider an example. I told you, if you want to write down a notes, you can write down the notes. Okay. For example, A is equal to 1, 2, 3, 4, 5. What is the cardinality of A? 5. And 4, 5, 6, 7, 8. What is the cardinality of B? Again it is 5. But if you observe these both, the elements, is both are same? No. 1, 2, 3 is not exist in the set B, whereas similarly 6, 7, 8 is not existing in the set A. The elements are different but cardinalities are being same. So hence these both are equivalent sets, and this is a notation of equivalent. A implies B. Okay. So this is nothing but an example of equivalent sets. So next we are going to discuss about worksheet problems, okay, of exercise 2 related to cardinality and equivalent sets. So I told you what is the other slide. So this is about equivalent sets. Let me take 2, 4, 6, 8, another example. What is the cardinality of set P? 4. Similarly 4, 6, 8, 2. These are also, maybe the order is different, but here also cardinality of Q is also equal to 4. These both are equivalent sets or not? Of course those both are equivalent sets, and at the same time these both are equal sets too. Equal sets too. So what I mean to say is equal sets are equivalent, but equivalent sets need not to be equal. అర్థమవుతుందా నాన్న? ఇప్పుడు ఈ కేసులోని 2, 4, 6, 8 ఫస్ట్ ఇవి ఈక్వల్ సెట్సా కాదా? ఈక్వల్ సెట్స్ అన్నప్పుడు మీకు ఏం చెప్పాను? యూ షుడ్ హ్యావ్ అ సేమ్ నెంబర్ ఆఫ్ ఎలిమెంట్స్ అండ్ సేమ్ ఎలిమెంట్స్. ఈక్వల్ సెట్స్లోని మీకు ఏం చెప్పాను? యూ హ్యావ్ టు గెట్ ఓన్లీ సేమ్ ఎలిమెంట్స్. ఏమున్నాయి? 2 ఉంది, జస్ట్ సి 4 is also there, 6 is also there, 8 is also there. Their order may or may be different, right? So these both are equal sets. P, Q are equal sets, and at the same time their cardinality n of P is also equal to n of Q is also equal to 4 over here, right? So what I mean to say is ఈక్వల్ సెట్స్ ఎప్పుడైనా ఈక్వివాలెంట్ సెట్స్ అవ్వచ్చు, బట్ దర్ కాన్వర్ట్స్ నీడ్ నాట్ బి ట్రూ. ఓకే, సో దిస్ ఈజ్ అ కాన్సెప్ట్ ఆఫ్ ఈక్వివాలెంట్ సెట్స్, difference between equal and equivalent sets, and the cardinality of set. So in the next slide we are going to discuss about some problems related to cardinality and equivalent sets. Okay, so today we are going to discuss about the session called worksheet number 2 of sets chapter. So what we have discussed up to today, so we discussed about the definition of set and types of set and cardinality of set and null set and void set and empty set. So all these definitions and how to express the set in two different formats like roster form and set builder form. So we discussed about all these things, right? And I also told you about the cardinality of set. So how do you define the cardinality of set? The number of elements in the set, right? For example, if you consider a set called X such that X belongs to N. So if you take any number, the number of elements, how many numbers or letters are exist in one particular type of set, then you will define it is a cardinality of set. So today we are going to solve some problems related to it. So let's begin the session. Okay, yeah. Set of lines joining the two fixed points represents a dash set. So set of lines. So how many lines will be there between two fixed points? Let me take out two fixed points. If I join these two fixed points, right, how many set of lines were there? Only one, correct? So two fixed points are connected by a single line, correct? By a single line. So you have only one line that was fixed with the help of two fixed points, right? Okay, so we have one line. Okay, so in that case it is having only singleton element. మీరు ఇక్కడ సెట్ ఫ్రేమ్ చేస్తున్నారు, ఆ సెట్ ఏమవుతుంది? హౌ యు ఆర్ ఫార్మింగ్ అ సెట్? దట్ వాజ్ ఫార్మింగ్ అ సెట్ with the help of two fixed points and it is only one. Clear? Am I clear with this? Can I get back to next question? If you are having only one element in the set, such type of set is called singleton set. What do you call? Singleton. Single means one, single, one. So if you have only one element in the set, I repeat again, how do you define a singleton set? If you have only single element, okay, if you have only one element, then we can conclude it is an singleton set. Can I get back to next one? Yeah. So what is the next question? Here comes the next question. Please read out. If two sets are not equal, for suppose if you are considering two sets, then tell me those sets are not equal. Okay, then they cannot be dash. So before solving this, you should also familiar of all these four option sets. Okay, what are the definition of these sets? So let me start. How do you define an infinite set? How do you define an infinite set? Infinite set is a set in which number of elements are uncountable. You cannot able to judge how many number of elements, you cannot able to predict how many elements are there in one set. You cannot able to count. Okay, so in that case you can define such type of set is infinite set. Okay, next one is finite. Finite means number of elements are countable. So in this case, in the set you will count the number of elements. You will count the number of elements. Next, null set. Null set means you will not have any you will not have any elements in the set. No elements in the set. No elements in the set. Right? Next. Next, singleton set. Singleton set. So how do you define null set? Can be defined in two different ways. If you have no elements in the set, that can also be equal to null set, and if you have found no common element from the both sets, then in that case also no common element, I can say like no common element in the set. I am adding just one word. Okay, no, null set is a set, no common elements were found between two different types of sets. Okay, that is defined as null set. And singleton set, if you have a single element, single or one element in the set. So what is asking you in the questions? If two sets are not equal, before solving this question, you should also learn what are equal sets. What are equal sets? For example, let me consider a set A is equal to 1, 2, 3. Okay, and B is also equal to 1, 2, 3. 1, 2, 3, right? 1, 2, 3. So in this set, you having the such type of elements. First element is also equal to first element in the second set. Second element in the set A is equal to second element in the set B. Similarly, third element in the set A is equal to third element in the set B. So if all the elements of first set are exactly got equal to second set, then we can conclude those type of sets are equal sets. And if I ask you what is the difference between equal sets and equivalent sets? Okay, I just telling you one other set. Next terminology is equivalent sets. Equivalent sets. So how do you define this? Equivalent sets. Yeah. Equivalent sets. How do you define this? What is the difference between this is an equal set? Yeah, this is an equal set, and what is the difference between equal set and equivalent set? For example, you may get a doubt like, let me consider a set 1, 2, 3, and let me consider a B set 3, 2, 1. Here, the first element in the first set is not equal to first element in the second set. 1 is not equal to 3, right? But number of elements in the same sets are equal. If the cardinality of two sets are equal, then we can say like it is an equivalent set. I define this: if cardinality of two sets are equal, then I can say those both are equal to equivalent sets. So I hope I am clear up to this. So what do you mean by this? Between equal sets in the case, consider any two sets, the first set and second set, and the arrangement of two sets. Like if you arrange the two sets, the first element in the first set and the first element of second set must be equal. Similarly, second and third. If you are having number of elements, that should be completely exactly equal to the same values of second set. Then you can say that those are equal sets. Okay. Whereas in the equivalent sets, the positions of elements, and if you take 1, 2, 3, that may not be equal to the same number in the first place. Okay. Here I am taking about number of elements should equal. Okay. If the elements in the positions are equal, then you can say that it is an equal sets. నేను ఏమంటున్నాను చాలా క్లియర్ గా, రెండు సెట్స్ తీసుకుంటే ఆ రెండు సెట్స్ లో ఫస్ట్ పొజిషన్ లో 1 ఉంది, సెకండ్ సెట్ లో కూడా 1 ఉంటే, సేమ్ ఎలిమెంట్ ఉంటే, ఫస్ట్ కి ఫస్ట్, సెకండ్ కి సెకండ్ కి థర్డ్ సేమ్ ఎలిమెంట్స్ ఉంటే వాటిని ఈక్వల్ సెట్స్ అంటారు. ఈక్వివాలెంట్ సెట్స్ అంటే నంబర్ ఆఫ్ ఎలిమెంట్స్ షుడ్ బి సేమ్. 4 ఉంటే ఫస్ట్ సెట్లో సెకండ్ సెట్లో 4 ఉండాలి, 3 ఉంటే సెకండ్ సెట్లో 3 ఉండాలి, 5 ఉంటే 5 ఉండాలి. దట్ మీన్స్ కార్డినాలిటీ షుడ్ సేమ్. ఇఫ్ ద కార్డినాలిటీ షుడ్ సేమ్, దెన్ ఇట్ ఈస్ అన్ ఈక్వివాలెంట్ సెట్స్. దట్ ఈస్ అ డిఫరెన్స్ బిట్వీన్ ఈక్వల్ అండ్ ఈక్వివాలెంట్ సెట్స్. ఐ హోప్ ఐఎమ్ క్లియర్ విత్ దిస్, రైట్? So we'll get back to this. If two sets are not equal, రెండు సెట్స్ ఈక్వల్ కాదు అని వాడు చెప్పాడు. దెన్ దే కెనాట్ బి ఇన్ఫైనైట్ సెట్స్ ఈక్వల్ ఆల్రెడీ కావు, అవునా? నెక్స్ట్ ఫైనైట్ సెట్స్ అవ్వచ్చు అవ్వకపోవచ్చు. దిస్ బెస్ట్ ఎగ్జాంపుల్ ఇస్ దిస్. ఓకే, దీస్ ఆర్ ఫైనైట్ సెట్స్ ఓన్లీ విచ్ ఆర్ కౌంటబుల్. ఇన్ దిస్ కేస్ దోస్ ఆర్ బీయింగ్ ఆల్సో ఈక్వల్, అవునా? కానీ వాడు ఇక్కడ ఈక్వల్ కాకూడదు అన్నాడు. దెన్ ద కెనాట్ బి నల్ సెట్, అవునా? దెన్ ద కెనాట్ బి నల్ సెట్. సో ఇట్ విల్ బి ఆప్షన్ సి. Am I clear with this? నల్ సెట్స్ కాకూడదు. ఓకే, నల్ సెట్స్ కాకపోతే అవి ఈక్వల్ సెట్స్ కూడా కావు. Shall I get back to next question? Yeah. For all these bits to attempt in a set chapter, you should be very much clear in the theory part, definitions part. So you should watch all the definitions and theory, then you can only you will attempt on your own. Okay, and you can also recreate the problems with your knowledge. Okay, can I get back to next one? Yeah. If the letters used in the rare and are represented in two sets. So let me take A is equal to ARE. Okay. Next one, set B is equal to REAR, represented in two different sets. Then the two sets are which sets? Then the two sets are which sets? Those are not infinite, that is clear. So it is not first option. Those are not null sets, you have elements in the set. So option B is also got deleted. You have elements, right? ARE and REAR. Those are not unequal sets. Alright. And next, if I go with a finite, yes, I can able to count. What are there in this? What are the elements? How many number of elements are there? 3. And how many number of elements are there in set B? 4. So that means it is finite. Okay, let's check with unequal. Unequal sets in the sense you should have like ARE and REAR. Here also the numbers, the letters ARE is being repeated. Here also ARE is being repeated, right? So it may also equal to unequal sets. Got it? So in both the sets we can able to find out the number of elements. We can able to count the number of elements in the set. So it is equal to finite sets. Okay. Can I get back to next one? My next question. If cardinality, if C is a set and it is defined as X is mapping from X minus 4 equal to 0, from this X value is equal to 4. From this X value is equal to 4. And D is a set, you are defining it like X is mapping from X square equal to 16. So X square is equal to 4 square, right? Also you can write like if X is square transformed to that side, it will become root 16, right? So then what are the possible values of X plus 4 and minus 4, right? So can you find a common element in this? Can you find a common element? Those are not infinite sets as usual. Please go through with it. Those are not infinite sets, correct? Those are not infinite sets because we can able to count how many number of elements are there. Those are not equal sets too because here you are having 4 and minus 4, here you are having only 4. In the first set you are having only 4, right? So let us represent in the set. See, here they have given set C, how many number of elements? 4. Set D, you are having minus 4 and plus 4. So those are not equal sets. First option is being deleted and second is also being deleted, right? And those are null sets? No, because you can find elements in this. So option C is also being deleted. But those are finite sets. Those are finite sets. Why? Because if you can see like those will be a finite sets. You can count number of elements in the C and D options, right? Yes or no? So option D will be your answer. Did you clear? So I just wrote x value is equal to 4 from the first set C, and x value can be equal to 4 and minus 4 from the second set, right? So that is the reason I wrote like those are finite sets. Can I get back to next question? Chalo. So what is my next question? If A is equal to x, x is mapping, x belong to natural number. You have to take such type of element that should be a natural number. Okay. What is that natural number? They only gave you like x is equal to 1, 1, 5, 6, 5, 5, 6, 3, 4. This is a natural number only, right? So this is completely a natural number. 11,55,634. That is a natural number. Then the cardinality of the set A is. So how many numbers you are taking here? X should be a natural number. So x is given like this 11,55,634. You are having only one number in the given set. So that means the cardinality of this is completely a one number only, right? The cardinality of this set is 1. The cardinality of set is 1. Am I clear with this question? You have to take such type of question, such type of answer, whereas x is a natural number and x should be this one. So the cardinality of this is 1, right? Yeah. So can I get back to next one? Next question. If n of c is equal to 4, means n of cardinality is equal to 4, you are taking one set. That means let us take 1, 4, 3, 5 are the elements. So what is n of c from this 4? Given n of c is equal to 4. Okay, means cardinality of set C is equal to 4. Then the set which cannot be C is. So what will be the cannot be the set C? So if you take the first option, let us go with option verification. So let us check with first option. Okay, so I told you when repetition is not allowed in the set, when the same letter is being repeated, it is very simple, you should write only for one time. So R and this is E and this is A. So this is REA, right? And this is READ, different letters. So cardinality of option B is 4 only. And this is also different letters, the cardinality is 4. Here also 4. Here also you have different letters. It is also the cardinality is 4. But whereas in the first option R is being repeated for the 2 times, right? So that is the reason option A and option A cannot be the answer. Why? R is being repeated and you have 3 elements only. Number of cardinality of this is equal to 3. So but given in the question number of cardinality must be equal to 4. So this cannot be the answer, right? So I hope I am clear with this question. Understood, Nana? Cardinality of this set must be equal to 4 అవ్వాలి. అలా చూసుకుంటే అన్ని ఆప్షన్స్ 4 అవుతున్నాయి except first option. So that will be your answer. Can I get back to next one? Can I get back to next question? Chalo, we'll get back to next question. So what is my next question? Please see here. If A అన్న set ఎలా డిఫైన్ చేశాడు? Let us define A set such that x belongs to x capital integers. So x integer అవ్వాలి, అలానే -1 less than x less than or equal to 0. Then the cardinality number of A is, అంటే number of elements of set A ఎన్ని ఉన్నాయి అని అడుగుతున్నాడు. He was asking you how many number of elements can be formed of the set A, right? So let us take x is an integer. X integer అవ్వాలి, first criteria. Second criteria, -1 is less than x, means x must be greater than -1 కదా. -1 x కన్నా చిన్నది, అంటే x -1 కన్నా పెద్దది అని రాసుకోవచ్చా? yes, so we can write like x is greater than -1. similarly x less than or equal to 0, right? so 0 కన్నా తక్కువ అవ్వాలి, 0 కైనా ఈక్వల్ అవ్వచ్చు. అంటే 0కి ఈక్వల్ అవ్వచ్చు అని చెప్పాను. 0 కన్నా తక్కువ అంటే ఇటు ఉంటాయి. సో మాక్సిమం నెంబర్ ఈజ్ 0 ఓవర్ హియర్, రైట్? సో 0 కన్నా తక్కువ అవ్వాలి, 0కి ఈక్వల్ అవ్వచ్చు. ఓకే, రైట్. 0 కన్నా తక్కువ అంటే ఏం నెంబర్స్ వస్తాయి? -1, -2, -3 అవి వస్తాయి. సో ఎక్స్ ఈజ్ గ్రేటర్ దాన్ -1 ఏం నెంబర్స్ ఉంటాయి? ఎక్స్ గ్రేటర్ దాన్ -1 అండ్ ఈ రెండిట్లకి ఇంటర్సెక్షన్ ఏం వస్తుంది చెప్పండి నాన్న. ఎక్స్ గ్రేటర్ దాన్ -1 అంటే మీకు ఏమవుతుంది? ∞ నుంచి స్టార్ట్ అయ్యి -3, -2, -1, right? and here you are having x greater than or equal to 0, less than or equal to 0. x less than 0 means you can take -1, -2, -3 up to 0, right? yeah. and what is a common number over here? What is the common number over here? x less than or equal to 0. First x less than 0 means -1, -2, -3, -4. All these are numbers in the second set. So you should form such type of things like -1 less than 0 separate. If you write separately you will form infinite numbers, but it should be a combination of such type of numbers. What I am taking is నేను ఇక్కడ ఏమంటున్నాను? x ఇంటిజర్ అవ్వాలి, పాయింట్ నెంబర్ 1. రెండోది -1 లెస్ దాన్ ఎక్స్ అంటే -1 లెస్ దాన్ ఎక్స్ అంటే ఇది ఎలా అవ్వాలి? -1 ఈజ్ ఎక్స్ షుడ్ బి గ్రేటర్ దాన్ -1 ఇది అవుతూ ఎక్స్ లెస్ దాన్ ఆర్ ఈక్వల్ టు 0 రెండు అవ్వాలి. ఇట్ ఈస్ నాట్ ఆర్, ఇట్ ఈస్ అండ్ స్టేట్మెంట్. సో వాట్ ఐఎమ్ టెల్లింగ్ యూ ఈజ్ జస్ట్ అ మినిట్. సి -1 ఈజ్ లెస్ దాన్ ఎక్స్ అంటే x గ్రేటర్ దాన్ ఆర్ ఈక్వల్ టు -1. -1 కన్నా పెద్దవి ఏమున్నాయి? 0, 1, 2, 3 అలా ఇవన్నీ వెళ్తాయి, రైట్? x గ్రేటర్ దాన్ -1 అంటే ఇక్కడ 0 ఉంది, రైట్? ఇక్కడ కండిషన్ ఏమొస్తుంది? అది ఎంతవరకు? హియర్ ఇట్ ఈస్ x లెస్ దాన్ ఆర్ ఈక్వల్ టు 0. 0 విల్ బీ దేర్ ఇన్ బోత్ ద సెట్స్, రైట్? x లెస్ దాన్ 0 మీన్స్ you will have -1, -3, -2 so on atla chaala numbers untayi. But I am not taking all these numbers. It should be a combination of both the sets. Two different sets kinda meeru represent cheskunte you will form infinite case. Nenu ikkada em antunanu? You need to frame such type of set. Do not get confused child. You need to frame such type of set. Meeru elanti elements rayali? First very clear, -1 కన్నా పెద్దవి. -1 కన్నా పెద్దవి అంటే 0, 1, 2, 3, 4, 5 అలా ఉంటాయి. బట్ దిస్ షుడ్ ఆల్సో బి ద కండిషన్, రైట్? ఈ రెండు క్లబ్ చేసి ఇచ్చాడు. దీస్ ఆర్ నాట్ డిఫరెంట్ కేసెస్. దిస్ ఈస్ అన్ ఇంటర్వెల్. సో హౌ యూ విల్ బి రైటింగ్ దిస్? ఓపెన్ ఇంటర్వెల్, రైట్? ఓపెన్ ఇంటర్వెల్ x is greater than -1. So x greater than -1 is -∞ to it will be ending up to 0, right? 0 and this will be like closed and in this set ikkada em vastundi? X is equal to 0. So ala anamata. So you will have two different cases. -1 kanna peddadi ante 0 nunchi start అవుతుంది, అంతేనా? 0 and ఇక్కడ ఆల్రెడీ 0కి ఈక్వల్, ఇంకా 0 కన్నా తక్కువ అంటే -1. సో అట్లీస్ట్ యూ ఆర్ హ్యావింగ్ ఓన్లీ 0 ఈజ్ ద ఎలిమెంట్, రైట్? దట్ ఈస్ వాట్ ఐ మీన్ టు సే. డు నాట్ గెట్ కన్ఫ్యూజ్డ్. -1 కన్నా పెద్దది 0. సెకండ్ కేసులో ఏముంది? x లెస్ దాన్ ఆర్ ఈక్వల్ టు 0. లెస్ దాన్ 0 అంటే మళ్ళీ -1. సో యుల్ హ్యావ్ ఓన్లీ సింగిల్ ఎలిమెంట్. బట్ -1 కెనాట్ బి ఇంక్లూడెడ్ బికాస్ ఇట్ ఈస్ లెస్ దాన్ x. ఇంక్లూడ్ చేయలేదు కదా ఇక్కడ. Here they have not mentioned equal to symbol, right? So it should be greater than -1 and less than or equal to 0. So greater than -1 less than or equal to 0 ante equal to 0 ఉన్నప్పుడు 0 ఉంది, greater than -1 అంటే 0 ఉంది. So you have only singleton 0 is the element. Did you understand? X greater than minus 1 ante 0 is the element. That is also a combination of x less than or equal to 0. Akkada 0 included. So we have only singleton element. So how many cardinality of this element is 1. Cardinality of this element is 1. I hope I am clear with this question. Understood, Amma? Am I clear with this question? Yeah. Can I get back to next one? So what is my next question? If L comma M comma R N are concurrent lines. So what do you mean by a concurrent lines? First of all, before solving this question, you should have the knowledge of definition of concurrent lines. So for example, if you take like this, so all these are concurrent lines, means it should pass exactly through one point of intersection. So this is called concurrent lines. Okay, you have a single point of intersection. Okay, the point of intersection is same for all the lines. Okay, it passes through all lines passing through one point. Passing through one point, right? So all lines passes through one point. So if you have a one point, let us read. If L comma M comma N are three lines here. So what are the lines here? Just a minute. Here you are having 1, 2 and 3. So this is L, this is M, this is N. So it passes through one point, right? Then the set of solutions of line is, solutions means how many point of intersection are there for concurrent lines? It is one line. So it will be a singleton set. It will be a singleton set. So again I will repeat this statement. Concurrent lines are such type of lines. No matter how many lines you take, all the lines should pass through one single point. So that single point will become a solution of those two lines, right? Yes or no? So then we'll have a single point. That means it is a singleton set. It is a singleton set. I am clear with this. Can I get back to next question? Chalo. So what is my next question? Read out the question along with me. If L is parallel to M, so line L is parallel to line M, E is parallel to M is parallel to N, and the transversal P, so always the transversal will be in the opposite direction. That is a definition of transversal. This is a transversal. If you draw a transversal at line L, just a minute, at line L you will have one point of intersection, similarly at M, similarly at N. So that means you are having 3 points of intersection. Then the cardinal number of those 3 lines is, then the cardinal number of those 3 lines, how many number of elements are there? 3, right? So that means the cardinality of these 3 lines is equal to 3. So if you take a transversal, the cardinal of these 3 lines is 3. 1, 2, 3, you are having 3 solutions, 3 point of intersections. So that means the cardinality is 3. I hope I am clear with this question. We will get back to next one. Yeah. What is my next question? If 2 circles are concentric, how do you define concentric circles? How do you define concentric circles? Having same center and different radii are concentric circles. Are concentric circles. So if you want to draw the figure, how you can draw? Draw the two circles having the same center for both the circles, right? Having same center but different radii. So these are called concentric circles. If you want to draw an image, this is the concentric circles. So what they were asking you, then the point of intersection of two circles, these two circles can meet ever? No, right? We cannot find any point of intersection of these two circles. So that means if you don't found a common element from the two sets, what are the two sets? Two different circles having a concentric circles. So we are having a same center but different radii, but we will not find a point of intersection of concentric circles. So and hence it will be a null set. So I hope I am clear with this video and all these questions about the sets and cardinality of sets and equivalent sets and equal sets. So in the upcoming sessions we are going to discuss more concepts and more problems. I hope you have enjoyed it. Thank you. Have a good day and good night to all. Bye bye.